Good morning to one and all. I'm Professor Raju Patil from Mechanical Department, Angade Engineering College, Belagavi. So today I am on the basis of metal cutting and forming. I will be conducting on the cutting forces in orthogonal cutting. Okay. In orthogonal cutting, the resultant forces are applied by the tool to the chip lies in the plane normal to the tool cutting edge. This can be determined experimentally by measuring in orthogonal components. Okay, in the direction of cutting, that is known as cutting forces F suffix H, and the other normal to the direction of cutting, that is known as thrust force F suffix V. Okay, with the help of dynamometers, the magnitude of resultant force may be found out as follows. That is, you all can see the formula, that is R is equal to root of F suffix H square plus F suffix V the whole square. Okay, the component of R in the direction of the width V is 0. Okay, you can see the sketch, you can refer the figure here. There is a workpiece. On workpiece, the tool has been touched to that chip, and chip and tool is one above the other meeting. Okay, you can see the motion of the workpiece shown in the arrow mark and the chip motion. Okay, how the chip is formed. Okay, the geometrical relationship of the components of the resultant force in other direction can be found out with the help of this figure. Okay, figure 2.10, with the help of this cutting force. Okay, and which shows the following angles and directions: shear plane pi, angle of friction theta, and tool rake angle alpha. You can see here, this is the theta, alpha, theta and pi. Okay, these following pairs of components are shown in selected directions: F suffix H, that is horizontal force component along cutting velocity vector; F suffix V, vertical force component normal to cutting velocity vector; F suffix S, that is force component parallel to shear plane AC. Okay, F suffix P, force component normal to shear plane. Okay, F suffix T, that is force component parallel to tool rake face. Okay, F suffix N, force component normal to tool rake face. Okay, so you all can, now we are referring this sketch and we are going to solve this. Okay, the cutting forces are, therefore R is equal to root of F suffix H the whole square, that is horizontal force square plus of vertical force square. Therefore R is equal to root of F suffix, that is force component parallel to the shear plane square plus force component normal to shear plane square. Therefore R is equal to root of force component parallel to tool rake face square plus force component normal to tool rake face square. Okay, if average coefficient of friction between the chip and the tool is mu, therefore mu is equal to tan theta is equal to F suffix T divided by F suffix N, that is what, force component parallel to tool rake face divided by force component normal to tool rake face. Okay, that is first equation. Also tan into theta minus alpha, that is equal to F suffix V by F suffix H, force component, that is horizontal force and vertical force. You all can see horizontal vertical force by horizontal force. That is equation 2. Comparing equation 1 and 2, we can use to find friction angle theta.  expressing different force components in terms of R pi, theta and alpha. Okay, f suffix s, that is equal to r cos into bracket pi plus theta minus alpha. F suffix p, that is equal to r sin into bracket pi 5 plus theta minus alpha. F suffix h is equal to r cos theta minus alpha. F suffix v, r sin theta minus alpha. Okay, therefore f suffix n is equal to r cos theta and f suffix t is equal to r sin theta. Theory of Ernest and Merchant. Okay, Merchant's model of orthogonal cutting is based on the assumption that shear plane pi should minimize the work done during cutting. Okay, remember this point. The assumption that shear plane angle pi should minimize the work done during cutting. Following assumptions are made: tool edge is sharp, shear plane is thin, deformation is in two-dimensional only, normal and shear stresses are disturbed uniformly on their shear plane. Okay, the work material is rigid and perfectly plastic. From figure 2.10, you all can see this. From figure 2.10, that is cutting forces, you all can see following relations are obtained. F suffix h is equal to r cos theta minus alpha. F suffix s is equal to r cos pi plus theta minus alpha. Let yield stress of material in shear, that is equal to k. Okay, f suffix s is equal to area into k. Okay, that is equal to ac. Okay, that is equal to ac into p into k. Okay, that is equal to t into p divided by sin phi into k. That is therefore that is equal to r is equal to f suffix s divided by cos phi minus phi plus theta minus alpha, that is equal to t into p into k, divided by sin phi cos into phi plus theta minus alpha. Therefore f suffix h is equal to t into p into k cos theta minus alpha divided by sin phi cos phi plus theta minus alpha. The energy consumption during machining, P suffix m is equal to f suffix h into v. Assume that phi and theta are not functions of cutting velocity v. Therefore d p suffix m d phi is equal to d f suffix h divided by d phi is equal to 0. Differentiate this equation 1 with respect to phi and putting equal to 0 for minimization of f suffix h. We get t into b into cos, that is into theta minus alpha into cos phi into phi plus theta minus alpha minus of sin phi into sin into phi plus theta minus alpha divided by sin square pi cos square pi plus theta minus alpha, that is equal to sin pi, that is not equal to 0, and cos pi plus theta minus alpha is also not equal to 0. Okay, so therefore cos pi plus theta minus alpha is equal to 0, cos theta minus alpha is not equal to 0. Therefore cos 2 pi plus theta minus alpha is equal to 0. Hence optimum value, you all can see here, optimum value phi is equal to pi by 4 minus theta minus alpha divided by 2. Did you all got this? Next we will be proceeding with problems. So determine the shear plane angle, cutting force component and resultant force on the tool for orthogonal cutting of a material with yield stress of 250 Newton per mm square. Following are the machining parameters. Okay, first one is tool rake angle, that is 15 degree. These are the given data. Tool rake angle is 15 degree. Uncut chip thickness, that is 0.25 mm. Chip width, that is 2 mm. Chip thickness ratio is 0.46. Okay. Angle of friction, that is 40 degree. Okay. Therefore, solution tan pi is equal to R1 cos alpha divided by 1 minus R1 R suffix t sin alpha. Okay, so therefore substitute the values in the formula. R suffix t, that is chip thickness ratio, that is 0.46, cos of rake angle, that is 15 degree, divided by 1 minus 0.46 sin 15 degree, that you get pi is equal to 29.57 degree. Okay, shear force along the shear plane F suffix S, that is TBK divided by sin pi. Substitute the values. What is T 0.25, chip thickness, that is 0.25, into B is width, that is 2 mm, into K is 250 mm. Okay, 250 divided by sin, whatever you have got that pi value, substitute that 29.57 degree, that F suffix S, that is load, you will be getting 279.04 Newton. Okay, the resultant force of cutting tool R is equal to F suffix S divided by cos pi plus theta minus alpha, that is equal to whatever we have got F suffix S, that load, have to substitute here. Okay, 279.04 divided by cos 29.57 plus 40 degree minus 15 degree. Okay, that is equal to 279.04 divided by cos 54.57 degree, that you will get 426.3 Newton. Force you will get, it is 426.3 Newton. Next, the cutting force component F suffix H, that is equal to R cos theta minus alpha, that is equal to 426.3 cos into 40 minus 15 degree, that will get 426.3 cos 25 degree. You will be getting horizontal force, that is 393.85 Newton. Okay, so we'll proceed with next one more problem we'll take in today's session. Determine the shear plane angle resultant force on the tool and cutting force component for orthogonal cutting operation of a material with shear yield strength of 200 Newton per mm square. The machining data is given below. Uncut chip length, that is 100 mm, length of cut length, that is 50 mm, rake angle of tool, that is 10 degree, width of cut, that is B, that is 1.5 mm, uncut chip thickness 0.2 mm, coefficient of friction, that is 0.8. Okay, so chip thickness ratio R1 R suffix T, okay, R suffix T is equal to L suffix C by L, that is L suffix C is length of the cut length, that is 50 mm, and the length is uncut, whatever the portion which is cut, that length you are going to take L suffix C, that is 50 mm, and uncut chip length you are going to take, that is 100 mm, it is given, that is equal to 0.5. Okay, R suffix C is 0.5. So tan pi, that is equal to R1 cos alpha divided by 1 minus R suffix T cos alpha divided by 1 minus R suffix T sin alpha. Okay, so that is equal to, if you substitute the values, R suffix T, you have got these values 0.5, substitute here 0.5 cos 10 degree divided by 1 minus 0.5 sin 10 degree, that is therefore shear plane angle you are going to get pi, that is equal to 28.34 degree. Okay, is that clear till here? So next, shear force along the shear plane F suffix S, you are going to refer this problem formula TBK divided by sin pi. So substitute the values. T is chip thickness, that is 0.2 mm. Okay, 0.2 into 1.5 width B into 200 divided by sin pi. Pi is you have got the, you have received the value 28.334 degree. So substitute that values. Resultant force on cutting tool, that is R is equal to TBK divided by sin pi into cos pi plus theta minus alpha. Tan theta is equal to mu, that is equal to 0.8. It is given coefficient of friction. Okay, theta is equal to tan inverse of this 0.8. You will be getting 38.66 degree. Okay, so therefore R is equal to 12 TBK. You will be getting this value is 126.3 divided by cos into 28.34 degree plus 38.66 degree minus 10 degree. That you will be getting 126.3 divided by cos 57 degree. So R you are going to get resultant force on cutting tool, you will be getting 232 Newton. Okay, so last we are going to find cutting force component. Cutting force component, F suffix H, that horizontal force, that is equal to R cos theta minus alpha, that is equal to 232. Resultant force you have got 232. Substitute the value. 232 cos into 38 theta, you have got 38.66 degree minus of 10 degree alpha. It is given in the problem. So that you will be getting horizontal force 203.58 Newton. Okay, with this we stop the class.